Today, we will try to understand about LLM monitoring. So, when I say LLM monitoring, that means like we use applications, right? So, for applications, we use to track the traces through, we have uh, Jagger, and for logs we use Loki, and for matrix we use Prometheus, and for visualization we use Grafana, right? So that is a traditional setup which we were using, but now we need to understand about LLM. LLM, let's say we have ChatGPT is one of the LLM, and we have Claude is one of the LLM, DeepSeek is one of the LLM, and so these are the LLM. So these are being monitored somewhere. That's why how they, improve, how they understand how their model is performing. Because we should track the progress. Only then we'll be able to understand our users and provide better features and keep on updating time to time, right? So, for this monitoring, today we will be discussing a very basic overview kind of thing. And it's like we use Olama, right? So, if we have to run the models locally, so we use Olama, and inside Olama, we can use open source model like Mistral, right? Quen. So these are the models which we can use, and we can check what traces we can capture, what logs we can capture, what matrix we can capture, and how we can alert, and how we can understand the users and the application performance or the infrastructure capacity planning we can do, right? Those things we can do. Now, so Langfuse is, I would say, an open source, and it is majorly designed for LLM tracing. Okay, so we can use Langfuse for, let's say, Mistral model. Okay, and so this is a kind of I would say setup, like we will understand like how things integrate, and how we uh, what things we you know collect to get the insight out of the application and out of the infrastructure. Now, we also have another tool, that is Phonics. So, Phonics is in another tool that is also used for tracing. So, it depends on choice, like which tool we want to pick from open source, and we can see what traces we can pull, and we can analyze for understanding the application, or to know the behavior of the LLM. Okay. So, LLM applications, it's a kind of application only, right? Like we have traditional application. In the similar way, we have LLM, because nowadays LLM is working like anything, because we can pull out informations, and we can do things at scale. We can uh, close things speedily, rather than going with the manual approach or with the traditional approach. It's like we are working on agents to do work for us, and that too, like like better time to market also, because it takes less time. We have uh, reducing the manual things and going more for agentic uh, AI, or like we have Gen AI, that is to get uh, a meaningful insight speedily rather than understanding the bunch of documents, and then we prepare something or we get insight out of any use case. So we will be integrating. It's a kind of like, while we will be discussing about this, so we'll be integrating Langfuse, Phonics, Prometheus, and Grafana. So it's kind of like we'll understand how these tools are helping us to get the insight out of our application or infrastructure. Then how these things run, right? So that is a kind of pipeline. So that pipeline, we run like a batch jobs we will be running, that is not like on immediate base or in the live environment. It's like we can run it off site or off production. um, there we discussed about cost optimization, like for those things we can use on spot instances, because those jobs can bear the interruptions, and we are okay because we are doing those things offline. Our customers are not getting impacted. So that is, and that's about so Olama, we understand it's a local LLM, and Langfuse, when I say it's an LLM observability, the usage of token, because we use tokens, right? The more the context we will give, the more the tokens it will use to process that input in order to give us the output, and that output would also be utilizing some tokens depending on the length of the output. So we want to track the cost. We want to track how much token is being used. So that is also a part of observability, because we want to observe so that we can control our cost, because like we are giving some context, we're giving some prompt to the system, right? Or maybe it is using our history, like previously what chats we have done. So that is also being retained in the system. It is ultimately, you know, causing a cost increase. So we should have an eye like how well we are managing the cost part. Now, then third thing comes error rate. Error rate means we have application. Similar way we have application in LLM application we also have. So like there could be timeout error in the application. Like I'm trying to access the application, but it is giving me timeout. Like the session, has been out, expired, or there should be content filter or model error, like there is some issue in the model or some issue in the rate limiting. Rate limit is a kind of quota we have, like per second that many request can accept. But if we are getting more requests, then we have to ask to raise a quota for rate limiting. And timeout is is scaling, because if we don't have enough resources, then it will time out because it is not getting the resources. So we have to do the capacity planning. That will be the part of timeout, because we are running out of resources. And maybe the model is experiencing some issue. So that is one of the, I would say, error which we get, error rate. Now, other things we have, uh, the rag pipelines. What we know about pipeline is pipeline, when we're talking about pipeline, so we have vector database. In the vector database, there is a data that we are retrieving, there is a generation that is being done, right? And there is a retrieval that is happening, right? So for those things, like we use like a search and generation and then coming back, how much time it is taking, right? Let's say we given a prompt, so that prompt will convert into embeddings like in numbers, and then that embeddings will find the meaning in the vector db, and then that will retrieve the embeddings from vector db, and then the llm will generate the output based on the context it got from drag system. So that also we need to track, like how much time it is taking to search or to generate, or to coming, and how many documents it is searching, because the prompt which we are giving uh, to the system in the RAG system. So it may search 10 documents. Based on 10 documents, it is giving us the input. Or maybe it just search only one document. Based on one document, it is giving us the input. So that also we need to track, like how many documents it is referring while answering our question. Then the matrix part, it's like in the LLM we have like loops, right? There is a reasoning loops that run. So how many loops are running while the agent is processing the information, and what is the success rate, what is the failure rate, and per tool how much latency is there, right? Because they were using multiple tools. So from multiple tools, it is pulling the information. Maybe one tool is getting more time to process the information and to give the output. So that we need to track which system is consuming more time. So it's and there is also scores. Like in ChatGPT, we used to give a feedback, a thumbs up or a thumbs down, right? So, or maybe we are commenting like we didn't like this answer, or it's weird, or it's very great answer we got. So that is a kind of feedback which we are giving to the model. So that is a score. So we can understand uh, the performance of our model, in which area it is performing well, and in which area it is getting worst comment or it is getting dislike, those things. Now, so it is all about LLM monitoring. We have understood